We often speak of the end of the world as a distant, terrible prophecy, yet life on Earth has already ended 5 times. 5 great silences have swept the continents, erasing 90% of all that lived as easily as dust from a table. These weren't slow declines, they were swift, brutal resets, each one a cosmic tremor we barely remember. We stand now on the fragile crust of the 6th such event. Tonight we peel back the veil of deep time to reveal the chilling truths of these forgotten cataclysms. Listen closely, for history whispers its warnings in the fossilized bones of the vanished. The Ordovician whisper. The first great extinction, the Ordovician, began not with fire, but with a sudden terrible freeze. For life, which was mostly confined to the shallow warm seas, this was a planetary death sentence delivered in glacial white. The event actually unfolded in 2 deadly pulses, a cosmic 1-2 punch that scientists are still struggling to fully understand, leading to a strange, ancient kind of silent dread. Imagine the great, unseen deep suddenly turning to ice, claiming 85% of all species. This first pulse was tied to a colossal drop in global sea levels, draining the vital shallow water habitats where most complex life thrived. The retreat of the oceans was so fast it would have been perceptible, stripping life bare to the sun. It suggests a vulnerability that still haunts us, that our greatest protection, the sea, can become our greatest weakness. The subsequent chilling pulse made survival nearly impossible for the creatures left exposed on the empty, shimmering coastal mudflats. Then came the thaw. The glaciers receded, but this was no reprieve. The melting ice created a different kind of monster, a devastating drop in oxygen levels in the deep seas. This anoxia turned the vast, unseen waters into a suffocating toxic soup, finishing what the cold began. It was a paradox. Life surviving the freeze only to be murdered by the return of warmth. This chilling cycle hints at a fundamental instability hidden in the Earth's delicate, ancient chemistry. Gamma-ray ghost. Some researchers whisper a terrifying possibility. The Ordovician event was triggered by a nearby gamma-ray burst. A single, fleeting flash of light from a dying star travelling across unimaginable distance could have ignited the entire extinction event in mere seconds. If a star thousands of light years away suddenly turned violent, we wouldn't even see it coming. It's a cosmic assassin that leaves no trace, delivering a silent, instantaneous death to a thriving ecosystem. Imagine the silent sky delivering judgment. This burst would have stripped the Earth of its protective ozone layer, that thin, vital shield in the upper atmosphere. The gamma rays would have instantly converted atmospheric nitrogen into nitrogen oxides, which then ate away the ozone. Within minutes, the fragile seal protecting surface life was gone, leaving the oceans and land exposed to raw, unfiltered solar ultraviolet radiation. It's a chilling reminder that our survival depends on a layer of gas we cannot even see. The effect on the shallow water plankton, the very base of the ancient food web, would have been immediate and catastrophic. The burst would have blinded and sterilized them, causing the bottom of the food chain to collapse instantly. Even worse, the nitrogen oxides would have caused a global smog, plunging the planet into a deep, dark freeze. It is a cosmic, dual horror. Instant radiation death followed by a long, lingering, light-starved winter. The Great Dying's silence. The Permian Triassic extinction, known chillingly as the Great Dying, remains the single worst event life has ever faced. 96% of all marine species vanished. 70% of land vertebrate families disappeared forever. This was not merely a reduction in life, it was a near-complete erasure, a silent cosmic undo button pressed on 252 million years of slow evolution. Only a handful of tough species survived to inherit a truly empty world, leading us to wonder how they were so uniquely blessed. The culprit is believed to be the Siberian traps, an unimaginably vast volcanic eruption in modern-day Russia that lasted for 1,000,000 years. This wasn't a mountain explosion, it was a colossal flood basalt event where lava poured out relentlessly over an area the size of Europe. The sheer volume of magma released would have darkened the skies for centuries and poured out greenhouse gases that rapidly cooked the planet. No modern catastrophe even remotely compares to this scale of persistent geological horror. The volcanic carbon dioxide triggered a runaway greenhouse effect, causing global temperatures to spike by 10 degrees Celsius. For marine life, this was fatal. The warmer water could hold less oxygen, leading to widespread ocean anoxia, the suffocating soup that returned with vengeance. Life fled the suffocating seas only to find the land scorched and barren. The Great Dying taught the chilling lesson that the very chemistry of life is a fragile prisoner of temperature. The hydrogen sulfide haze. As the oceans warmed during the Great Dying, a far more sinister killer emerged from the depths: hydrogen sulfide gas. When deep-sea oxygen levels vanished, anaerobic bacteria that thrive in toxic mud flourished and began to produce this lethal gas. Initially confined to the seabed, the gas eventually bubbled up to the surface in massive stinking plumes. Imagine the oceans turning into a vast, silent chemical factory, deliberately manufacturing poison to kill the world above. These plumes grew so large that they began to escape the ocean and spill over onto the land, coating coastal areas and poisoning the atmosphere. Scientists suggest that the amount of hydrogen sulfide in the atmosphere became deadly enough to kill land animals, causing a mass die-off of plants and creatures along the shores. This toxic haze would have had a distinctive, terrifying smell of rotten eggs, signalling that the entire planet was officially succumbing to sickness. The sulphurous gas not only killed, but also attacked the last remaining ozone layer, leaving survivors doubly exposed. The land was being suffocated by poison, while simultaneously being sterilized by the sun's raw ultraviolet radiation. This dual attack suggests the Great Dying was a self-perpetuating apocalypse. Life was not just dying. It was being actively unmade by its own environment, a terrifying feedback loop of environmental horror that wiped out nearly all competitors. The coal-fire horror. A terrifying theory proposes that the eruption of the Siberian traps did more than just release lava. The colossal lava flows ignited vast underground reserves of coal and oil, turning the entire eruption into an underground wildfire on a planetary scale. These ignited carbon deposits released unimaginable quantities of noxious gases and soot into the atmosphere, blackening the skies for centuries. It was not a conventional volcano. It was the world's fossil fuel reserves spontaneously setting themselves ablaze in a furious, prolonged conflagration. The smoke and soot from these burning coal beds would have created an extinction winter, plunging the planet into a deep, chilling darkness that lasted for years. Plants, starved of a light, would have died off rapidly, causing the entire land food chain to shatter. The air would have been thick with choking ash and poisonous fumes, a lethal cocktail that few land animals could endure. This suggests the Great Dying wasn't just a warming event, but a chaotic, dark, suffocating apocalypse that struck from above and below. Evidence for this subterranean inferno comes from unique traces of ash and soot found in the Permian Triassic boundary layers across the globe. These burnt carbon spheres, called fly ash, are clear signatures of massive coal combustion. This means the death of life was written in its own carbon history, a haunting foreshadowing of modern environmental peril. The horror is that the greatest destruction came not from nature, but from Earth's own fuel reserves. The longest day in hell. The Great Dying may have taken place over a terrifyingly short period of geological time, perhaps only 60,000 years. While this sounds long to us, it means the extinction unfolded at a pace faster than new species could evolve or adapt, creating immense evolutionary pressure. The survivors were not necessarily the best or strongest, but those lucky enough to already possess the rare traits needed to survive a poisoned, scorched world. The oceans became so acidic that life with shells, like clams and corals, simply could not survive. The very chemistry of the water actively dissolved their defences. The entire Permian seafloor, once a colourful garden, turned into a vast, empty graveyard of crumbling limestone and broken shells. It's a chilling thought that the ocean, the cradle of life, could become a deadly corrosive bath, where calcium was forbidden. The land experienced a fungal spike. In the fossil record just above the boundary layer, scientists find an overwhelming abundance of fungal spores. This suggests that when all the plants and trees died off, the world was left covered in a massive banquet of decaying matter, leading to a temporary kingdom of mould. For a brief, terrifying moment, the planet was ruled by silent, rotting fungi. The dinosaurs' phantom ancestors, before the dinosaurs ruled their ancestors, giant lizard-like creatures called archosaurs, were devastated by the end-Triassic extinction. This event, roughly 200 million years ago, was crucial because it wasn't the biggest, but it was the most selective. It wiped out nearly all of the dinosaurs' competition, clearing the stage for the true age of reptiles. It was a cosmic game of chance where the dinosaurs happened to hold the winning ticket. This extinction is strongly linked to another colossal volcanic event, the formation of the Central Atlantic Magmatic Province, CAMP. Much like the Siberian traps, lava spewed out, covering huge areas that would eventually become parts of North and South America, Africa, and Europe. This event injected enough carbon dioxide into the atmosphere to heat the planet, and once again plunged the oceans into toxic anoxia. The most chilling effect of the end-Triassic event was how it seemed to favour specific survivors. Small, agile creatures that could burrow, or those that could tolerate high temperatures and acidic food, survived the ecological bottleneck. All the large, slow-moving archosaur rivals vanished, leaving the ancestors of the dinosaurs to quickly evolve into the terrifying giants we remember. Extinction is a cruel hand, but sometimes it is the hand of opportunity. The ocean's empty heart. The oceans of the late Triassic period were home to massive, strange marine reptiles, including the ichthyosaurs and placodonts. They were the reigning kings of the ancient seas, yet they disappeared almost completely during this time. The rapid and extreme swings in ocean chemistry and temperature overwhelmed even these apex predators. It proves that no creature, no matter how powerful or dominant, is immune to a planetary system in crisis. The extinction caused marine communities to remain impoverished for millions of years afterwards, a biological vacuum that took huge amounts of time to refill. Scientists call this the recovery interval. It's a period of deep shame in the Earth's timeline, where the oceans, once teeming with life, resembled a vast, silent, and nearly empty blue desert. The silence of the seas after an extinction is perhaps the most terrifying sound of all. One key victim was the massive reef systems. Corals are famously sensitive to ocean acidification and warming. The end-Triassic crisis destroyed nearly all the great reef structures, which function as underwater cities' nurseries, with "the city's gone, the citizens followed." This vulnerability of reefs remains a terrifying warning sign, indicating that entire complex ecosystems can be undone by slight chemical shifts, the volcanic shadow. The immense eruptions that created the camp region did not release their deadly gases all at once. Evidence shows the eruptions occurred in 4 major phases, separated by millions of years. This meant life was given a brief period to recover between disasters, only for the trauma to be renewed again and again. It was a cycle of hope followed by crushing despair, a relentless geological torture that wore down the resilience of all species. The initial pulse of carbon likely caused a massive immediate climate shock, but subsequent pulses made the extinction irreversible. Each new pulse reinforced the toxic feedback loops, making the oceans warmer, more acidic, and less oxygenated. It's like a wound that refuses to heal, with the planet tearing itself open repeatedly to ensure the death of its inhabitants. The Earth has a terrible, persistent memory of how to self-destruct. The timing of the end Triassic extinction is almost perfectly matched with the first major pulse of camp volcanism. This synchronization is one of the strongest pieces of evidence that catastrophic volcanic activity, and not an asteroid, was the main trigger. It replaces the sudden terror of a space rock with the slow, inevitable horror of a planet turning against itself, boiling and choking its own surface life. The Devonian drowning. The late Devonian extinction, spanning millions of years, is sometimes called the Age of Fishes dying. It was a prolonged, complex crisis, marked by multiple smaller extinction pulses rather than one single catastrophic event. Scientists suspect a terrible combination of factors, including massive sea level changes and an expansion of deep-sea anoxia. It was a slow, agonizing death for the seas, not a sudden execution, making it feel more like a relentless, creeping disease. One frightening theory suggests that the rise of the first great forests on land caused the marine extinction. As these massive new trees colonized the continents, their root systems dramatically changed the soil chemistry. Runoff washed huge amounts of nutrients into the oceans, triggering massive algal blooms that consumed all the oxygen when they died. Life on land accidentally murdered life in the sea, a perfect, tragic ecological betrayal. The victims were disproportionately the creatures of the tropical reefs, especially the great reef-building corals. These systems were permanently destroyed, unable to cope with the influx of toxic, nutrient-rich water. This extinction left an indelible mark. Every reef you see today has roots that only go back to the survivors of this devastating, prolonged crisis. The past is still scarred by the revenge of the water. The Black Shale Time Capsule. The Devonian extinction left behind extensive layers of black shale in the fossil record. This black carbon-rich rock is essentially a frozen snapshot of the anoxic, poisoned oceans. It contains huge amounts of undecayed organic matter, proving the water was so starved of oxygen that even the smallest decomposers could not survive. These black layers are a persistent, dark memorial to the suffocation of the ancient marine world. Black shale layers indicate that the deep oceans rose and spilled their toxic contents onto the continental shelves. This process is called upwelling, where the poisoned depths essentially boiled over into the shallow waters. Imagine the dark, bottomless abyss sending its vengeance up to punish the bright surface world, carrying with it a lethal payload of heavy metals and hydrogen sulfide. These layers of black shale are often rich in metals like uranium and arsenic, indicating that the oceans became not just oxygen-starved, but highly toxic. These metals, trapped in the oxygen-free sediments, would have poisoned any life that dared to burrow or settle near the seabed. This suggests the Devonian was a chemical massacre, where life faced a double threat: suffocation and heavy metal poisoning. The Kelwasser event pulse. Within the long Devonian crisis, the Kelwasser event stands out as a particularly severe, sharp pulse of extinction. This is identified by two distinct layers of black shale, separated by a brief return to normal rock, suggesting a rapid double blow. It was a moment where the slow, creeping disease suddenly flared into a terminal illness, wiping out species with shocking speed before briefly receding. The Kelwasser layers mark the disappearance of nearly all tropical marine species. This strong bias toward the warm water dwellers suggests that a massive, sudden cooling or an extreme shift in water circulation was the trigger. Tropical life, which is highly specialized and intolerant of change, was instantly erased, while creatures living in colder or deeper waters had a slightly better, though still grim, chance of survival. This specific event is noted for the sudden disappearance of conodonts, tiny eel-like marine vertebrates whose tooth fossils are crucial dating tools. Their sudden vanishing act is a silent marker in the rock record, telling scientists that the world changed irrevocably in that moment. The loss of these tiny timekeepers is itself a kind of chilling historical silence, leaving a gap in the ancient timeline. The rise of the land plants. The evolution of tall, complex land plants was a triumph, but it came at a terrible cost. Before the Devonian, land plants were short and simple. When they grew tall, they developed deep, powerful root systems that broke down rock much more efficiently than before. This act of colonization dramatically accelerated the washing of minerals into the sea. This massive influx of nutrients acted as a catastrophic overdose for the oceans. It created vast dead zones, areas where the oxygen was entirely consumed by blooming algae. The very success of plant life on the land led directly to the failure of animal life in the sea. It is a haunting example of how evolutionary success in one domain can be lethal in another. The plants also pulled immense amounts of carbon dioxide out of the atmosphere, causing global temperatures to drop rapidly. This cooling effect, coupled with the suffocating anoxia, delivered the final death blow. The Great Devonian forests, which seemed like a symbol of vitality, were in fact a silent, powerful climate engine that drove the world into a lethal dark age. The Frasnian-Furmenian boundary. The two main pulses of the late Devonian extinction are named the Frasnian and Furmenian events. The first pulse, Frasnian, was more severe, targeting the warm water organisms. The second pulse, Furmenian, finished off the remaining cold water survivors and reshaped the entire ecosystem. This reveals a pattern of planetary collapse, an initial shock that targets the most fragile, followed by a second blow that cripples the resilient. In the aftermath, the evolutionary recovery on land was glacially slow. While marine life was decimated, the tetrapods, the first four-legged animals emerging onto land, struggled for millions of years. This long struggle, often called Romer's Gap, is a dark period in the fossil record, lacking clear evidence of diversification. It proves that a great silence on land often follows a great drowning in the sea. The Devonian crisis essentially set back the colonization of land by millions of years. The world that emerged was stripped of complexity, an impoverished stage waiting for the eventual evolution of amphibians and reptiles. The trauma of this extinction left a lingering ghost in the biosphere, limiting the potential of land-based life for an entire geological period. The vanished fish. The Devonian is called the Age of Fishes because of the immense diversity of the early armoured fishes, known as placoderms. These terrifying massive predators, like Dunkleosteus, vanished completely. They were replaced by the ancestors of modern bony fish and sharks. The sudden and absolute removal of these ruling armoured giants cleared the evolutionary space for faster, less armoured fish to dominate the subsequent world. The armour that had protected the placoderms for millions of years became their downfall. The sheer size and rigidity of their bodies meant they could not adapt to the rapidly changing oxygen and temperature levels. Their success became their prison, proving that too much specialisation can be a liability when the world shifts violently. The smaller, more generalised survivors inherited the Earth. The complete disappearance of an entire class of dominant, successful life is one of the most chilling aspects of the Devonian. No descendant of a placoderm swims today. Their extinction was total and absolute. They exist only as massive, terrifying ghosts in the fossil record, a permanent reminder that evolution sometimes throws away its masterpieces entirely. The Cretaceous Asteroids Warning. The final, most famous extinction, the Cretaceous Paleogene, or KPG event, is famous for the asteroid that killed the dinosaurs. But the real horror is that the Earth had been giving warning signs for millions of years. Massive, sustained volcanic activity in the Deccan Traps region of India had already begun poisoning the air and destabilizing the climate long before the rock arrived. The eruptions in the Deccan Traps were so immense that they released carbon dioxide and sulfur dioxide on a scale that dwarfed all modern human emissions. This led to climate chaos, massive swings between global warming and short periods of cold. The asteroid was not the sole killer. It was simply the final devastating blow delivered to an already sick, weakened planet struggling to survive. Fossil evidence shows that some species were already in decline before the impact, suggesting a world under stress. The ecosystem was frayed, making it incredibly susceptible to sudden shock. The asteroid didn't kill a healthy world, it ended a dying one. This is a terrifying revelation, that a planet already struggling is ripe for a final sudden collapse when faced with the inevitable hammer blow. The iridium ghost. The defining signature of the KP extinction is a thin, mysterious layer of iridium found globally in the geological record. Iridium is extremely rare in the Earth's crust but abundant in asteroids. This thin, dark stripe in the rocks marks the very moment of impact, the planetary scar of the disaster. Every geologist who sees this line is looking at a terrifying cosmic signature of instantaneous planetary death. The global distribution of this iridium layer proves that the impact was a truly planetary event, spreading cosmic dust around the entire world within weeks. It was a global burial shroud, a fine layer of extraterrestrial dust blanketing every continent, darkening the skies and signalling the end of the dinosaurs' long reign. This dust is the physical proof of an alien killer. This layer of dust, which represents the entire pulverized asteroid, is not just iridium. It contains shocked quartz and microtectites, tiny glass spheres formed when molten rock is instantly solidified in the atmosphere. These minute, beautiful spheres are the literal tears of the Earth, cried out when the impact vaporized kilometers of the planet's surface in the space of a single second. The Chicxulub smoking gun. The crater, responsible for the KP extinction, the Chicxulub crater, lies hidden beneath the Yucatan Peninsula in Mexico, half on land and half under the sea. It is over 180 kilometers wide, a circle of cosmic violence. It remained hidden for decades, an invisible wound on the planet's surface, until subtle gravitational and magnetic anomalies revealed its terrifying structure beneath the sediments. The impact point was disastrously unlucky. The asteroid hit a region rich in sulfur-bearing gypsum. This instantly vaporized, releasing massive amounts of sulfur dioxide into the atmosphere, far more than a hit in basalt rock would have done. This sulfur formed highly reflective aerosols that blocked the sun, plunging the world into an immediate and devastating global winter. The impact also triggered immense global earthquakes, magnitude 10 or 11, shaking the entire planet to its core. These quakes, in turn, triggered massive, widespread volcanism in the already active Deccan Traps, creating a deadly synergy of fire and brimstone. The single impact event simultaneously unleashed seismic, atmospheric and volcanic forces, creating a complete and absolute planetary collapse that allowed nothing to survive unscathed. The firestorm of death. The immediate effect of the Chicxulub impact was a colossal global firestorm. The material ejected from the crater shot high into the atmosphere, vaporizing as it fell back down around the world as searing red-hot debris. The atmospheric temperature rose instantly, causing forests and grasslands everywhere to spontaneously combust. Life on the surface was incinerated within hours by an invisible worldwide wave of incandescent heat. The vast, unseen wave of thermal radiation would have caused massive collective death. Even animals that were not directly burned would have suffocated as the oxygen was consumed by the planetary firestorm. The immense fires released enough soot into the atmosphere to completely blot out the sun for years, plunging the world into a nuclear-style winter that lasted long after the initial blast. Only creatures that could hide, those that burrowed deep underground, lived far underwater, or were small enough to shelter quickly, had any chance. Everything large and exposed, including 99% of the dinosaurs, was condemned by the heat flash and the ensuing darkness. The survivors of the KP extinction were those who could embrace the shadow and the cold. Proving invisibility was the ultimate evolutionary advantage. The perpetual darkness. The most damaging long-term effect of the KPG impact was the perpetual darkness caused by the soot and sulfur aerosols. The sun was totally blocked for months, leading to a catastrophic collapse of photosynthesis. Without sunlight, plants died first, then the herbivores that ate them, and finally the mighty carnivores that preyed on the herbivores. The Great Pyramid of Life collapsed from the bottom up. The global cooling that followed the impact was not the true killer. The darkness was. The lack of light, called the impact winter, was an instantaneous starvation event that lasted long enough to wipe out every major land food chain. It proved that light itself is the most fragile and necessary resource, and its temporary absence can undo millions of years of life. In the post-apocalyptic world, the only ecosystems that survived were those based on detritus, decaying matter. The creatures that ate seeds, roots, insects, and carrion were the inheritors of the earth, eventually evolving into the age of mammals. The dinosaurs were not defeated by a bigger, stronger predator, but by the smallest things, a lack of light, and the persistence of shadow. The Great Dying Silence, Permian Terror, the Permian supercontinent. The Great Dying happened when nearly all the land masses were merged into the supercontinent Pangaea. This vast single landmass created immense dry and unstable interiors, leading to extreme temperature swings and minimal biodiversity. This geography of isolation meant that when the Siberian traps began to erupt, there was nowhere for life to hide, making the entire planet a single vulnerable target. The formation of Pangaea itself was a slow, crushing extinction event, long before the volcanic blast. The merging of coasts eliminated vast amounts of shallow marine habitat, stressing life for millions of years. This initial geological pressure made the subsequent volcanic blast all the more lethal, proving that even plate tectonics can act as a slow, inevitable executioner. The consolidation of Pangaea led to massive climate zonations, with large, dead deserts in the interior. This lack of moderating ocean influence meant that temperatures swung wildly between scorching heat and freezing cold, a brutal environment that challenged the limits of biological adaptation. Life was already running on empty when the ultimate disaster arrived. The carbon catastrophe. The Siberian traps released an estimated 100,000 billion tons of carbon into the atmosphere, a quantity that is almost unimaginable. This was not a quick release, but a sustained, relentless injection of greenhouse gas over hundreds of thousands of years. The planet was essentially placed inside a slow cooker, causing temperatures to rise without any chance for the natural cycles to absorb the pollution. This massive carbon load led to the terrifying phenomenon of runaway warming. Once the ocean started to heat up, they released even more carbon stored in deep-sea sediments, creating a lethal feedback loop. The Earth itself was amplifying the initial volcanic insult, turning a major catastrophe into the worst extinction in history. The planet turned into its own worst enemy. The carbon isotope signature in the Permian boundary layer shows an alarming spike, confirming the sudden, massive influx of light carbon from volcanic or burned sources. This distinct chemical fingerprint is the proof of the massacre, a ghostly residue that tells scientists precisely what kind of poison killed the world. It's the permanent, etched signature of a planetary murder. The poisoned seas. During the Great Dying, the deep oceans became totally anoxic, meaning they were completely devoid of oxygen. This created vast dead zones that rose from the depths to consume the coastal seas. As these zones expanded, the area where marine life could thrive shrunk to an impossibly thin layer near the surface, trapped between the toxic depths and the baking atmosphere above. This anoxia allowed the proliferation of sulfate-reducing bacteria, the same organisms responsible for the lethal hydrogen sulfide gas. The Permian oceans were literally stewing in a noxious chemical bath, producing a massive amount of poison that eventually spilled onto the land. The deep sea, the largest volume of water on Earth, became a hostile chemical factory of death. The unique fossil record of marine life at this time shows a dramatic depth gradient of death. Creatures living on the deep sea floor died first, followed by those in slightly shallower water. The final survivors were plankton near the surface, proving that the killer rose from the unseen abyss, consuming the oceans layer by layer from the bottom up. The fungal aftermath. The fungal spike that followed the Great Dying was short-lived but absolute. When the land plants died, they left behind immense fields of dead wood and organic matter, a perfect habitat for fungi. The explosion of fungal spores in the fossil record is the strongest evidence of a total collapse of terrestrial ecosystems, proving that primary producers, the plants, were wiped out almost instantly. This fungal dominance means that the period immediately after the extinction was defined by decay. Instead of green forests, the survivors saw a landscape dominated by the silent white or brown rot of decomposing life. The world became a massive compost pile, a graveyard where the fungi were the temporary opportunistic rulers, thriving on the planetary tragedy. The sheer volume of dead plant matter also meant that the recovery of the surviving plants was severely hampered. Fungi compete with new seedlings for nutrients, delaying the return of forest for millions of years. This initial fungal reign extended the extinction's reach, ensuring that the planet remained a barren, desolate canvas for a geological age. The Lilliput effect. Following the Great Dying, life experienced the Lilliput effect, a chilling phenomenon where surviving species rapidly shrank in size. For millions of years, the average size of marine and terrestrial animals plummeted. Larger bodies require more food, more stable environments, and more oxygen, all resources that were critically scarce in the devastated Permian world. Shrinking became an evolutionary strategy for survival. Smaller creatures need less food, reproduce faster, and can regulate their body temperature more efficiently in chaotic climates. The world after the Great Dying was a place where giants were punished and only the smallest, most desperate survivors were allowed to live. The Earth forced life to retreat into miniature forms. This trend is starkly visible in the fossil record of conodonts and certain marine invertebrates, which became dwarfed after the extinction. The Lilliput effect is a biological scar, showing that the planet's resource capacity had been fundamentally reduced. Life could only persist by becoming smaller, faster, and more humble, living in the shadow of the vanished giants. The Lazarus taxa. The Great Dying is responsible for the phenomenon of Lazarus taxa. These are species that vanish entirely from the fossil record during the extinction event, only to mysteriously reappear millions of years later, seemingly resurrected. Their disappearance is not extinction, but a forced retreat into a geological invisibility cloak. They were so rare and isolated that they left no trace for millions of years. The fact that these species survived in hidden, isolated refugia for so long is a testament to the Earth's capacity to harbour life in the darkest times. However, their sudden reappearance is also a chilling marker of the long, silent recovery. The vast gap in the fossil record between their vanishing and their return represents the true, silent duration of the trauma. The most famous example is the coelacanth, a living fossil fish. Though its lineage stretches back 400 million years, it was thought to have vanished completely during the KP extinction, only to be rediscovered alive in 1938. The Lazarus taxa remind us that the ocean still holds secrets, and that some species can survive the apocalypse by simply going deeper into the shadow. The salt mine horror. The Siberian Trap's volcanic activity is suspected of igniting massive salt deposits, which release large amounts of toxic chlorine into the atmosphere. This chlorine would have caused devastating acid rain, burning vegetation, and poisoning surface waters across the globe. The rain was not cleansing. It was corrosive, falling from the sky like a chemical weapon designed to strip life from the land. The acidic oceans, combined with the acid rain on land, created a planetary environment that chemically hostile to all complex life. The land was stripped of nutrients by the constant toxic downpour, and the seas became lethal to anything that needed a calcium shell. This dual chemical assault made the Great Dying unique in its intensity and scope. The scale of this underground salt ignition and chlorine release is hard to comprehend. It suggests that the lava flows were not just heat sources, but vast chemical mixers, tapping into every toxic reserve the Earth held and unleashing it into the environment. It transforms the volcano from a simple mountain of fire into a complex, unstoppable instrument of chemical warfare against life. The missing coal. A terrifying aspect of the aftermath of the Great Dying is the coal gap. For about 10 million years following the extinction, virtually no new coal deposits formed anywhere on Earth. Coal is formed from decaying plant matter, and its absence proves that the forests and peat swamps necessary for its creation were completely eliminated. This gap is a silent, chilling testimonial to the destruction of the planet's primary producers. The world was so ecologically sterile for that immense period of time that the building blocks of future fuel simply did not exist. The 10 million years without coal represents a planetary famine, a sterile age where the life cycles necessary to create forests were utterly broken. The return of coal deposits only signals the slow, agonizing recovery of the global flora. The first coal formed after the gap is often different, signaling that the species responsible for peat formation had been permanently replaced by the hardier survivors. The coal gap is a physical record of the planet's darkest, most ecologically empty moment. The reptilian inheritors. The Great Dying wiped out the synapsids, the dominant creatures that were the ancestors of mammals. The survivors were a few small, durable reptiles who quickly diversified in the empty world. This mass elimination allowed the archosaurs, the ancestors of crocodiles and dinosaurs, to claim the dominant role on land, initiating the Mesozoic era. The extinction created a profound evolutionary vacuum. With the synapsids removed, the surviving reptiles faced minimal competition, allowing them to rapidly evolve into massive, terrifying forms that ruled the Triassic. This event proves that the greatest evolutionary leaps often follow the deepest, most absolute catastrophes. Death, in this case, was the ultimate catalyst for new life. The reptiles that inherited the Earth were generally better equipped to handle the arid, unstable climates of Pangaea. Their scaly skin and hard-shelled eggs gave them an advantage over the skin and reproduction of the proto-mammals. The Great Dying was, in essence, a brutal cosmic selection process that permanently shifted the balance of power on land toward cold-blooded dominance. The vanished shells. The Permian oceans were home to vast numbers of shelled invertebrates, including brachiopods and trilobites. The trilobites, which had survived every crisis for over 250 million years, were finally and utterly wiped out. Their shells, which had protected them against all previous disasters, were no defense against the rising heat and corrosive acidity of the dying sea. The complete removal of the trilobites is one of the most chilling aspects of the Great Dying. They were the ultimate survivors, the perennial dark horse of the Paleozoic era. Their absolute failure proves the uniqueness and severity of the Permian event. It was a killer that transcended all previous biological defenses and adaptations. The shells of these creatures left behind a deep layer of limestone that abruptly ends at the Permian-Triassic boundary. This geological abruptness is the silent, perfect marker of their absolute vanishing. It is a line in the stone that separates a world teeming with ancient, alien-shelled life from a world that was suddenly and permanently stripped bare of its ancient Anoxia pulse. The Devonian extinction was characterized by repeated pulses of ocean anoxia, where the seas lost oxygen, making them unlivable. These pulses were directly linked to the massive influx of nutrients from the newly formed land forests. The rise of terrestrial life had an invisible, terrible consequence for its aquatic cousins, an ecological crime scene millions of years in the making. These anoxic events were global, showing up in the fossil record in the famous black shales across many continents. This planetary synchronicity suggests a worldwide environmental failure driven by a single colossal mechanism. The entire ocean system, from pole to pole, seems to have choked at the same time, proving that global ecosystems are dangerously interconnected. The Devonian extinction pulses lasted for about 25 million years, a staggeringly long time for the Earth to remain in a state of crisis. This long, drawn-out horror means that species were not only killed by the events, but also by the sustained chronic instability that followed. The duration of the sickness was almost as lethal as the disease itself. The deep sea drowning. The Devonian crisis was particularly devastating to deep-sea life. The dark depths, usually stable refuges, became the initial killer as anoxic water rose. Creatures that had adapted to the absolute pressure and cold of the abyss suddenly faced a lethal lack of oxygen. The safe darkness became a suffocating trap, consuming the life it had long protected. The creatures that lived in the deep were often strange and highly specialized, relying on the stability of the ocean's bottom layers. Their sudden disappearance proves that the very currents and circulation patterns of the ocean must have fundamentally inverted. The predictable flow that sustained them was replaced by a churning chaos that brought up the poison. The fossil record shows a massive drop in the diversity of benthic life, organisms that live on the seafloor. This loss removed a vital part of the ocean's nutrient recycling system. The death of the deep-sea scavengers and filter feeders accelerated the ocean's decline, creating another self-perpetuating death spiral from which the system struggled to escape, the algal bloom monster. The influx of terrestrial nutrients during the Devonian caused massive globe-spanning algal blooms. These blooms, often a dark, swirling green, were not life, but a terrifying sign of imbalance. As these huge masses of microscopic life died, their decay consumed all the dissolved oxygen in the water, creating vast, sterile dead zones across the continental shelves. The sheer scale of these ancient blooms would have turned the seas into a terrifying, murky soup. Sunlight would have been blocked from penetrating the water, killing the deeper plants and corals that needed light to survive. It was an invisible war fought by single-celled organisms whose collective death resulted in the end of complex marine life. These ancient blooms left behind unique organic molecules in the sedimentary rocks, the chemical signature of their massive sudden population explosion. These invisible molecules are the physical proof that the triumph of life on land led to the chemical murder of life in the sea, a profound example of ecological cause and effect across the globe. The reefs of shame. The Great Barrier Reef systems of the Devonian were enormous, built by strange alien-looking corals called rugose and tabulate corals. These massive structures were the foundation of the entire marine ecosystem, but they were almost completely destroyed by the successive extinction pulses. The ocean's most complex cities were reduced to rubble. This reef destruction created a long-term problem for the entire ecosystem, similar to knocking down every major city on a continent at once. The loss of these stable, protective habitats meant that the complexity of the marine food web was simplified, and many species that relied on the reefs for spawning or protection vanished forever. The long-lasting nature of the Devonian crisis meant that corals struggled to rebuild for millions of years. Every time a new reef system tried to establish itself, another anoxic pulse or climate shift would destroy it. The Devonian is a geological period marked by the planet's frustrating inability to sustain the conditions necessary for complex reef life to thrive. The cold snap killer evidence suggests that at least one of the Devonian pulses may have been caused by a brief but intense global cooling event. The massive burial of carbon from the newly evolved forests pulled huge amounts of greenhouse gas out of the atmosphere, causing temperatures to plummet rapidly. This sudden cold shock would have been devastating to tropical marine life. The transition from a warm, stable climate to a sudden cold snap would have caught the slow-moving, specialized marine creatures completely off guard. Their metabolic systems were unable to cope with the rapid drop in temperature, leading to mass die-offs. The irony is chilling. The forest that brought life to the land inadvertently froze the life in the seas. This climate whiplash, from stable warmth to sudden cold, followed by anoxia, proves the profound instability of the Devonian climate. The combination of geological forces and the powerful new biological engine of land plants created a chaotic environment where no creature could reliably adapt. The Devonian teaches that rapid change, regardless of its direction, is the ultimate killer. The end of armoured fish. The extinction marked the end of the placoderms, the iconic heavily armoured fish of the Age of Fishes. Their disappearance was total, wiping out an entire evolutionary branch that had dominated the seas for 70 million years. This mass loss of armoured giants fundamentally changed the nature of marine predator-prey dynamics, favouring speed and stealth over sheer power. The placoderms, despite their strength, were too slow and specialised to survive the environmental chaos. Their heavily calcified skeletons made them vulnerable to the acidifying oceans, and their large bodies made them sensitive to the lack of oxygen. Their armour, once a shield, became a cage that condemned them to extinction. The final, chilling disappearance of the placoderms cleared the way for the evolutionary dominance of the chondrichthyans, sharks, and osteichthyans, bony fish. These lighter, more flexible, and more adaptable groups of fish were able to survive the crisis and exploit the empty ocean niches, proving that the end of one tyranny is the beginning of another. The ghost of the first forests. The first true trees, like Archaeopteris, were magnificent, strange plants that covered the Devonian landscape. Their disappearance during the extinction pulses is a major mystery. They were so successful at building forests that their sudden failure suggests a massive, sustained environmental shock that wiped out even these powerful new terrestrial organisms. Their fall was likely due to the combination of acid rain and the long-term changes in soil chemistry caused by their own roots. They poisoned the ground and were killed by the resulting chemical imbalance, a tragic act of ecological self-sabotage. The death of the world's first forest set back terrestrial evolution dramatically, leaving the land barren and open for millions of years. The massive amounts of carbon buried by these first forests were eventually oxidized during the extinction, released back into the atmosphere to fuel the cycle of climate chaos. The trees died, but their carbon lingered, creating a lasting legacy of environmental instability. Their ghost is the carbon they released, haunting the climate for ages. The Romer's Gap, silence. The period immediately following the Devonian extinction on land is known as Romer's Gap, a 15 million year period in the fossil record where tetrapod fossils are almost non-existent. The earliest four-limbed creatures struggled so fiercely that they left almost no trace of their existence, an immense silent void in the history of land vertebrates. The gap suggests that the land environment was utterly hostile, perhaps choked with fungal decay, acidic soil, and extreme climate volatility. Only a few, tiny, desperate survivors managed to cling to life in isolated pockets, preventing them from leaving widespread fossils. The land was so inhospitable that it acted as a geological censor, wiping out the historical record of its first conquerors. Romer's Gap is a powerful reminder that evolutionary success is never guaranteed. The movement from water to land, one of life's greatest triumphs, was nearly undone by this massive crisis. The vast silence of the gap proves that the earlier steps onto land were taken under the most hostile, terrifying conditions imaginable. The global sea level collapse. The Devonian extinction was marked by catastrophic global sea level fluctuations. As the climate shifted between warm and cold periods, glaciers formed and melted repeatedly, causing sea levels to rise and fall dramatically. This instability constantly destroyed the shallow water habitats, which are the most biodiverse areas on the planet. These rapid changes in sea level created immense ecological stress, forcing species to constantly migrate or die as their homes appeared and vanished. The constant movement prevented the establishment of stable, complex communities, weakening the ecosystem's ability to cope with other shocks like anoxia. Instability, not just the temperature change itself, was the key killer. The constant shifting between exposure and drowning severely limited the geological record, making it difficult to find continuous fossil sequences. The chaos of the Devonian is written in the very brokenness of the rock strata. The ancient seas were victims of a planetary whiplash, constantly pulled and pushed by an unstable global climate engine. The extraterrestrial trace. While the Devonian extinction is primarily linked to terrestrial and marine events, some theories suggest an extraterrestrial trigger, such as a comet or asteroid impact, may have delivered the initial shock. Trace amounts of impact-related minerals have been found in the Devonian boundary layers, but the evidence is not as clear as the KPG event. The search for a hidden Devonian impact crater is one of geology's great mysteries. If one exists, it would explain the sheer scale and suddenness of the extinction pulses. The possibility that a comet or asteroid merely destabilized an already stressed planet, tipping it into self-destruction, is a terrifying thought about cosmic vulnerability. The most chilling part is that the Devonian event may have required a combination of forces: the growth of land plants to destabilize the oceans, and a cosmic impact to deliver the final shock. It suggests that a planetary crisis can be the result of a deadly synergy between internal and external forces, making prediction or prevention impossible. The Camp eruptions. The end-Triassic extinction is directly linked to the formation of the Central Atlantic Magmatic Province, Camp, a massive volcanic zone. These eruptions began roughly 200 million years ago, marking the final breakup of Pangaea. The sheer volume of magma spewing out over 500,000 cubic kilometers of rock created a geological event of world-altering proportions. The Camp eruptions were not a single event, but a series of massive, rapid pulses occurring over a short period of about 600,000 years. Each pulse injected massive amounts of carbon dioxide and sulfur into the atmosphere, causing repeated environmental shocks. Life would start to recover, only to be hit again by another wave of volcanic poison. The eruptions occurred simultaneously on 4 different continents that were then part of Pangaea: North and South America, Africa, and Europe. This proved that a single geological event could cause synchronous catastrophe across a vast planetary scale. The Earth tore itself apart, and the resultant chaos killed nearly all life outside the dinosaur lineage. The acidic rain of fire. The massive release of sulfur dioxide from the Camp eruptions created intense corrosive acid rain. This rain would have fallen across the entire supercontinent, poisoning lakes and rivers and severely damaging plant life. The water cycle, which sustains life, became a means of chemical delivery, raining down destruction from a sky turned toxic. The acid rain also had a profound effect on the oceans, contributing to ocean acidification that targeted shelled marine life. The ability of corals and mollusks to build their protective shells was chemically inhibited, leading to mass mortality. The seas became a lethal, corrosive bath, where the fundamental building blocks of life were denied. The fossil record shows clear evidence of plant damage just before the extinction boundary, consistent with severe acid rain exposure. The leaves of ancient plants show pitting and scarring, the silent, etched proof of a relentless, corrosive assault from the atmosphere. Even the mightiest forests could not withstand the rain of fire from above. The vanishing amphibians. The end-Triassic extinction was especially cruel to amphibians. Their porous skin, which allows them to breathe, also made them incredibly vulnerable to the acid rain and chemical toxicity of the surface water. Their habitat, the freshwater lakes and swamps, became instant chemical weapons, transforming their safe homes into mass graves. The loss of amphibians created an ecological void in the transition zones between land and water. These creatures were vital links in the food chain, and their sudden vanishing disrupted entire ecosystems. The event proved that the most specialized, geographically restricted creatures are often the first victims of a planetary environmental crisis. The amphibians that survived did so by retreating into tiny, isolated pockets of clean water, or by adopting life cycles that were more resistant to dry, acidic conditions. Their modern descendants are a resilient yet silent reminder of a time when the entire class was nearly erased by the toxicity of the world they inhabited. The crocodilian mystery. While nearly all the dominant land reptiles were wiped out, the ancestors of modern crocodiles, known as crocodilomorphs, not only survived, but thrived. This is a strange paradox. The extinction that killed the mighty dinosaurs' ancestors spared their scaly, low-slung rivals. Crocodiles are, in many ways, the ultimate survivors of the Triassic apocalypse. The key to their survival was likely their semi-aquatic lifestyle. The ability to retreat into large bodies of water provided a buffer against the worst of the atmospheric heat and acid rain on land. Their generalist diet also allowed them to survive when specialized food sources vanished. Adaptability and retreat were their ultimate weapons. Modern crocodiles are living monuments to this disaster, embodying a body plan that has barely changed since the Triassic. They are a constant, cold-blooded reminder that the evolutionary victory was not about becoming the fastest or the largest, but about possessing the resilience to survive planetary chaos by dwelling near the water's edge. The recovery vacuum. The end Triassic extinction created a profound ecological vacuum on land, eliminating all the large non-dinosaurian archosaurs. This sudden and selective removal cleared the playing field, allowing the remaining small feathered bipedal dinosaurs to rapidly evolve and dominate the next era. The catastrophe was, for the dinosaurs, a cosmic blessing in disguise. The dinosaur ancestors were not dominant before the extinction. They were a minor group living in the shadows of larger, more successful rivals. The volcanic event selectively targeted their competitors, creating an environment where the dinosaurs' unique traits, like their upright stance, suddenly became highly advantageous for survival. The sheer speed of the dinosaur ascent after the extinction is chilling proof of the power of ecological emptiness. In a world suddenly purged of competition, evolution moves at a terrifying pace, rapidly filling the available niches. The age of dinosaurs began with an act of geological violence that cleared the way for their terrible 135 million year long reign. The marine reptile purge. The end Triassic extinction was devastating for marine reptiles like the ichthyosaurs and plesiosaurs, although they were not completely wiped out. The massive swings in ocean temperature and acidity were enough to eliminate nearly all the massive slow-moving species. The crisis was a biological purge that fundamentally redefined the aquatic food chains. The creatures that survived were the smaller, more generalized ichthyosaur species that could tolerate a wider range of environmental conditions. Their larger, more specialized cousins, the apex predators of the Triassic seas, vanished completely, proving that even the kings of the sea are subject to the merciless laws of planetary chemistry. This marine purge opened up ecological space for a new wave of marine life in the Jurassic, including the further diversification of the remaining marine reptiles. However, the initial shock left the Triassic oceans impoverished for millions of years. The enduring trauma of the deep sea is a silent record of a time when the water actively rejected its most powerful inhabitants. The dolomite mystery scientists have noted the widespread deposition of dolomite, a specific type of limestone, around the time of the end Triassic event. Dolomite formation is sensitive to chemical conditions, and is sometimes linked to massive releases of methane gas, which is an extremely potent greenhouse gas. This suggests an added layer of lethal gas contributing to the climate chaos. The methane would have been released from deep-sea clathrates, frozen stores of methane gas in the seabed. The warming of the oceans caused by the volcanic carbon dioxide would have destabilized these stores, causing massive methane eruptions. This is another terrifying feedback loop. The volcanoes start the warming, and the oceans finish the job. Methane is a much more powerful warming agent than carbon dioxide, meaning a massive clathrate release would have caused an immediate, intense spike in global temperatures, delivering a rapid, lethal shock to the biosphere. The dolomite layers are the silent geological marker of this hidden gas weapon, a cosmic signature of a sudden, intense fever. The tropical nightmare. The end-Triassic extinction was especially severe in the tropical regions. This bias suggests the primary killer was heat, as tropical life is already near its upper temperature tolerance and cannot adapt to further warming. This massive selective die-off in the warmest zones is a terrifying indicator of a runaway greenhouse effect taking hold across the globe. The loss of tropical biodiversity means that the planet's evolutionary engine room was temporarily shut down. Tropical regions are typically the source of new species that later spread to temperate zones. The sterilization of the tropics severely limited the pace of global recovery, extending the evolutionary silence for millions of years. The fossil record shows a massive drop in the diversity of pollen and spores in tropical regions, proving the widespread devastation of plant life. The land was stripped bare in the areas that should have been the most lush and vibrant. The terror of the Triassic is that the places that should have been safest became the most fatal. The pterosaurs' lucky break. The extinction was beneficial for the early pterosaurs, the flying reptiles. While they were not initially dominant, the end-Triassic event eliminated their competitors, including a group of gliding reptiles called Quainosaurids. This sudden removal cleared the airspace, allowing the pterosaurs to rapidly evolve into the dominant flyers of the Jurassic and Cretaceous periods. The pterosaurs' survival was likely due to their high metabolism and ability to range over vast distances, helping them escape the local ecological disasters caused by the camp volcanism. Their unique adaptation for flight provided them with a mobility buffer against the widespread toxicity and chaos on the surface. The pterosaurs' victory is another example of a catastrophic event acting as an evolutionary reset button. A minor group of flying reptiles inherited the vast, empty sky, a massive niche opportunity created by the sudden, selective removal of their rivals. The price of their success was the absolute demise of almost everything else. The hidden killers. While volcanism is the primary suspect for the end-Triassic extinction, the true killer was the multitude of deadly invisible effects it triggered. The lethal chain reaction, volcanism leading to carbon, carbon leading to warming, warming leading to anoxia, and anoxia leading to hydrogen sulfide, is the real horror. The original wound was just the starting pistol for the planet's slow, self-inflicted death. The geological record is so abrupt that it suggests the final collapse was triggered by a rapid, intense tipping point. The planet crossed a threshold where the feedback loops became unstoppable, leading to the rapid and total failure of entire ecosystems. The final moments of the Triassic were likely characterized by terrifying, unpredictable changes in the environment. The end-Triassic extinction is a chilling reminder that the greatest threats are often unseen and interconnected. It was not the fire of the volcano or the heat of the sun alone, but the complex self-amplifying chemical weapons that emerge from the Earth's own natural systems that ultimately wiped the slate clean for the next era of life. The Gondwanan glaciation. The Ordovician extinction's first pulse was caused by a sudden, massive period of glaciation centered on the supercontinent of Gondwana. Ice sheets grew rapidly, locking up vast amounts of water and causing a devastating drop in global sea levels. This rapid freezing was the death knell for life, which had previously only known a warm, stable world. The ice sheets were so extensive that they caused a massive climate flip, moving the planet from a warm, ice-free state to a glacial nightmare in a geological blink. This extreme climate whiplash was the main cause of mortality. demonstrating that a planet's climate can switch from a greenhouse to an icehouse with terrifying speed. The Ordovician event proved that life's reliance on warm, shallow seas was its fatal flaw. The creatures had no evolutionary preparation for global ice. When the warmth vanished, so did the vast majority of all living things, leaving behind the chilling image of an entire era frozen in the rock, victims of a sudden, silent winter. The shallow water graveyard. The glaciation caused sea levels to drop by as much as 100 metres, exposing vast areas of the continental shelves. These shallow waters were the nursery and home for nearly all of the Ordovician's biodiversity. When the waters receded, these complex ecosystems were instantly destroyed, leaving behind vast, empty mudflats baking under the sun. The loss of these shallow habitats was absolute and irreversible. Species that could not quickly migrate to deeper water were left stranded, suffocating on land or dying from rapid temperature exposure. The Ordovician extinction was a massive collective stranding, where the tide of a frozen climate simply refused to return. The subsequent reflooding of the shelves was no reprieve. The returning water was cold and often anoxic, carrying toxic chemicals from the deeper, stagnant ocean. Life that survived the freeze was then killed by the poisonous thaw. This double-edged disaster made the Ordovician one of the most selective and effective killers in history. The cosmic flaw. The rapid onset of the Ordovician glaciation suggests that the Earth's carbon cycle was suddenly and violently disrupted. Some theories point to a rapid, weathering event that pulled enormous amounts of carbon dioxide out of the atmosphere, robbing the planet of its greenhouse blanket and triggering the freeze. The rapid removal of carbon may have been caused by geological activity or by the sudden, intense action of a nearby gamma-ray burst. The burst would have destroyed the ozone layer, leading to chemical changes that drastically reduced atmospheric carbon. The cosmic flaw was not just the freeze, but the sudden theft of the atmosphere's warmth. This sensitivity to atmospheric carbon proved to be the ultimate weakness of the Ordovician biosphere. Life was thriving under a delicate, unseen balance, and the sudden removal of a tiny fraction of atmospheric gas was enough to condemn the entire world to ice. The climate system was found to be far more fragile than previously assumed. The graptolites collapse. The graptolites, tiny colonial organisms that drifted in the Ordovician seas, were almost completely wiped out. These creatures were a massive part of the plankton community, the base of the food web, and their disappearance shattered the entire marine ecosystem. Their fossils are often found in dark, carbonaceous shales, the silent witnesses of the anoxia that killed them. The collapse of the graptolites suggests that the surface waters, the euphotic zone, were severely affected by the gamma-ray damage and the subsequent cold. As primary producers, their death led to a cascade failure, proving that the health of an entire food web is dependent on the most fragile, smallest organisms at the bottom. The few surviving graptolite species were the hardiest, rapidly evolving into new, smaller forms in the post-extinction world. Their temporary disappearance and subsequent rebound mark a period of intense evolutionary pressure. The graptolite story is a chilling reminder of how close the entire marine ecosystem came to absolute collapse. The end of the nautiloids. The nautiloids, massive ancient cephalopods with magnificent coiled shells, were the apex predators of the Ordovician seas. Their large size and need for stable oxygen levels made them particularly vulnerable to the anoxia and cold. Their massive die-off cleared the way for the eventual rise of fish as the dominant marine predators in the later Devonian. The loss of these ruling shelled predators was a major ecological blow. Their shells, which had long protected them, became a burden in the acidic, low-oxygen waters. Their vanishing act is a key marker of the Ordovician severity, signalling the end of an era where shelled invertebrates ruled the planet's seas. The survivors were smaller, more generalized nautiloids, often with simpler shells, who managed to persist in isolated deep-sea refugia. Their diminished descendants are a biological echo of a former glory, a constant, quiet reminder that even the most terrifying rulers can be humbled by a planetary catastrophe. The dual crisis model. The Ordovician extinction is best understood as a dual crisis model, a cold glacial shock followed by a warm anoxic shock. The initial freeze was caused by a sudden drop in atmospheric carbon, and the subsequent thaw released the trapped meltwater, creating toxic, stagnant oceans. Life was killed by two completely opposite yet equally lethal environmental extremes. This dual nature made the extinction particularly effective, ensuring that any species adapted to survive one extreme was inevitably wiped out by the other. Life was given no refuge, no stable environment to adapt to. The relentless alternation between freezing and suffocating conditions guaranteed a near-total collapse of marine biodiversity. The ultimate lesson of the dual crisis is that stability is the true foundation of life. When the Earth's systems enter a chaotic, alternating state of extreme temperatures and chemical toxicity, even the most robust ecosystems will fail. The Ordovician was a trial by fire and ice, designed to test the limits of planetary resilience. The Siberian iceberg. Some theories propose that the Ordovician glaciation was amplified by the unique arrangement of the continents, especially the positioning of Gondwana near the South Pole. This geographical arrangement provided the perfect conditions for massive ice sheet formation, trapping the water and beginning the sequence of disaster. The movement of the continents themselves acted as a trigger for the extinction. The sheer coincidence of Gondwana being positioned at the pole at the exact time the carbon was removed was an unhappy planetary alignment. This suggests that the fate of the biosphere is often determined by the slow, inevitable dance of the tectonic plates. The subsequent breakup of Gondwana eventually led to the end of the glaciation, proving that the slow march of geology is the ultimate controller of planetary climate. The Ice Age ended when the continent drifted away from the pole, showing that the greatest climate catastrophes can be solved by simply changing the Earth's long-term geography. The land's early ghost. Even in the Ordovician, when life was still overwhelmingly marine, there is evidence of the first primitive land plants, like moss spores. The extinction likely created a major setback for this early colonization of the land. These fragile first pioneers were instantly doomed by the climate chaos and the lack of moisture. The few terrestrial survivors were those that could withstand freezing and desiccation, retreating into microscopic forms to survive the glacial period. The Ordovician extinction serves as a forgotten filter, removing the vast majority of all potential land life before it ever truly began its evolutionary journey. The few scattered fossils of these early land plants are a chilling reminder that the conquest of the continents was almost undone before it started. The entire history of land life, including us, hinges on the survival of a few microscopic spores during a period of intense global cold. The shadow of the Ordovician touches everything that walks. The mass burial. The sharp boundary of the Ordovician extinction is often represented by massive sudden fossil graveyards. These beds of rock contain the remains of vast numbers of trilobites, brachiopods, and other shelled organisms that died at precisely the same time. These mass burial sites are the physical proof of the instantaneous nature of the disaster. The sheer density of the fossils in these layers indicates that the environmental shock was so rapid that it killed entire communities before they could decompose or be scattered. The fossil beds are literal minutes in geological time, preserving the final, agonizing moments of an entire era's marine life. These mass burial sites are the most sobering evidence of planetary catastrophe. They represent not just death, but a moment of collective doom, where millions of individual lives ended together, forming a single permanent scar in the Earth's crust. Every piece of rock at this boundary is a tombstone from the ancient silence. The silent recovery. The recovery from the Ordovician extinction was one of the slowest in Earth's history. lasting over 20 million years. This protracted period of evolutionary silence proves the severity of the damage inflicted on the marine ecosystems. The life that returned was simpler, less diverse, and genetically impoverished compared to the world that had vanished. The long recovery was hampered by the persistent instability of the climate, with minor anoxic events continuing to plague the oceans for millions of years. The planet was stuck in an unstable equilibrium, constantly threatening to fall back into crisis. Life had survived, but it was fragile, tentative, and shadowed by the memory of the collapse. The organisms that eventually diversified were the descendants of the toughest survivors, small, generalist species that could tolerate low oxygen and fluctuating temperatures. The New World was built on the humble foundations of the few that made it through the fire and ice, proving that sometimes the greatest strength lies in the capacity for smallness and persistence. The global tsunami, the Chicxulub impact, instantly triggered a colossal megatsunami, a wave hundreds of meters high that raced across the Gulf of Mexico and into the surrounding coastlines. This wave was an immediate killer, reaching inland hundreds of miles, ripping apart coastal ecosystems and creating massive scour marks visible in the geological record today. The power of this tsunami was unlike anything recorded in human history. It carried massive boulders and debris far inland, depositing them in chaotic, jumbled layers that mark the exact moment of the impact. The sudden violence of the water was the first major blow to life immediately after the asteroid hit. The tsunami's devastating power was concentrated around the Caribbean, but seismic waves would have caused massive tsunamis in all the major oceans, even those far from the impact site. The entire world's coastlines experienced a moment of instant, terrifying, watery chaos, proving that no part of the planet was safe from the aftershocks of the cosmic hammer. The impact winter, the soot and aerosols released by the impact firestorm and the vaporized gypsum created an intense impact winter. This period of global darkness and freezing temperatures lasted for months, killing off most of the plant life necessary to sustain the food chain. The asteroid strike was in effect a massive immediate climate engineering disaster. The sheer volume of reflective sulfur aerosols blocked up to 90% of all sunlight, plunging the Earth into a profound twilight. The global temperature plummeted by as much as 20 degrees Celsius. This sudden, prolonged cold was the fatal blow, condemning the large, warm-blooded dinosaurs to a slow, inevitable starvation and freeze. The impact winter did not need to last forever. It only needed to last long enough to destroy the base of the food web. Once the plants died, the herbivores had nothing to eat, and the carnivores followed. The asteroid delivered not a direct kill, but a carefully engineered catastrophic famine that was irreversible. The sulfur smog. The asteroid impact hitting the gypsum beds of the Yucatan released enough sulfur dioxide to create a dense toxic smog that blanketed the world. This sulfur smog would have been extremely corrosive, leading to a massive global episode of devastating acid rain that followed the initial firestorm and tsunami. The acid rain poisoned the surface, waters, rivers and lakes, killing off freshwater life and further damaging the already struggling plant life. The acid rain was so intense that it likely contributed to the ocean acidification that wiped out much of the shelled plankton, the microscopic foundation of the marine food web. This sulfur smog was the physical mechanism that sustained the darkness of the impact winter. The fine sulfur particles acted as perfect light reflectors, holding the sun's warmth out and extending the period of global cooling and plant starvation. The geological poison of the impact site was the key to unlocking the planetary collapse. The shocked quartz. One of the most profound pieces of evidence for the Chicxulub impact is the presence of shocked quartz grains, found globally in the iridium layer. These quartz crystals show microscopic parallel lamellae, structures that only form under the extreme pressure of a massive impact or a nuclear explosion. They are the planet's fingerprint of cosmic violence. These shocked quartz grains are essentially tiny, perfect records of the impact's force scattered across the entire planet. Their ubiquitous presence proves that the energy released was truly global, vaporizing and reforming rock with an unimaginable power that permanently scarred the Earth's mineral structure. The fact that these tiny, scarred grains of rock are found thousands of miles from this crater is a chilling reminder of the impact's sheer scale. It proves that the disaster was not a regional event, but a single, instantaneous blow that physically scattered material from the impact site to the most distant corners of the globe. The teardrops of glass. The impact instantly melted rock and vaporized the ground at the crash site. As this molten rock was ejected into space, it cooled almost immediately, raining back down around the world as tiny glass spheres called microtectites or spherules. These miniature beautiful teardrops of glass mark the moment the Earth cried molten tears. The microtectites settled across the globe, forming a fine layer of extraterrestrial residue that lies just below the iridium layer. They are the physical evidence of the speed and intensity of the impact, proving that kilometers of the Earth's crust were instantly liquefied and thrown into a suborbital flight. The survival of these delicate glass spheres proves that the planet's surface was briefly rendered molten. The existence of these tiny, perfect geological products of catastrophe is a chilling contrast. Beautiful, pristine glass spheres marking a moment of absolute planetary destruction. They are the most profound and elegant signature of the doom. The deep sea killers. While the land burned and froze, the deep ocean seemed to have escaped the initial heat flash. However, the subsequent collapse of the surface food chain meant that the rain of organic material that sustains the deep sea suddenly stopped. The deep sea ecosystem starved in a slow, prolonged famine that lasted for thousands of years. The extinction event created a profound ecological uncoupling between the surface and the abyss. The cold, dark depths were safe from the fire, but they were utterly dependent on the life that the fire had destroyed. The deep sea died a slow, quiet death of starvation, proving that even the most remote parts of the planet are not immune. The marine fossil record shows a severe decline in deep-sea foraminifera, tiny single-celled organisms at the base of the deep-sea food chain. Their disappearance is a chilling signal that the life support system of the entire abyss was turned off, leading to a vast, prolonged silence in the deepest parts of the world. The dinosaurs' final hour, the KPG extinction, was not total for the dinosaurs. The surviving lineage, the ancestors of modern birds, managed to persist. Their smaller size, feathered insulation, and ability to eat seeds and small insects gave them the advantage. The massive, impressive dinosaurs died because they were too large, too specialized, and too committed to a non-flying lifestyle. The non-avian dinosaurs vanished completely, their enormous bones abruptly stopping at the iridium layer. The sudden and absolute removal of these dominant reptiles cleared the way for the age of mammals. The greatest evolutionary transformation in 100 million years was decided by the difference between being a 6-ton tyrannosaur and a half-pound protobird. The few tiny birds that survived were the ultimate inheritors of the dinosaur empire. They endured the fire, the darkness, and the famine by living in the shadows and eating the smallest seeds. Their survival is a humbling reminder that when the world ends, the victory goes not to the mighty, but to the meek and the small. The folly of size. The KP extinction established a clear, terrible rule. Anything over 25 kilograms was highly unlikely to survive on land. Large animals need vast amounts of food, which the plant die-off instantly eliminated. Their low reproductive rates also meant they could not rebound quickly enough to exploit the resources that eventually returned. This size-based filtering meant that the entire land biome was reset to creatures the size of small dogs or smaller. The world entered a long phase of miniature life, where the evolutionary clock had to start over from the level of small burrowing mammals. The catastrophe established a temporary no giants allowed zone on the planet. The small mammals, our ancestors, survived by being generalists and scavengers, able to eat insects, roots, and decaying matter. Their ability to live underground protected them from the heat flash and the initial cold. The sheer scale of the dinosaurs was their tragic, fatal flaw, while the tiny body size of mammals was their salvation. The post-impact inferno-geological evidence suggests that after the impact winter, the climate dramatically rebounded into a superheated greenhouse period. All the carbon dioxide and sulfur released from the impact eventually began to warm the planet, causing a new, intense spike in temperatures. Life had to survive a whiplash, rapid freeze followed by rapid bake. This chaotic, alternating climate state, cold, then hot, severely hampered the recovery process. The surviving ecosystems, already stressed, struggled to adapt to the relentless swings between freezing winter and scorching summer. The planet remained unstable for thousands of years, preventing any fast return to biological complexity. This post-impact heat pulse is a final, cruel reminder that the asteroid did not deliver a single disaster, but unlocked a sequence of self-amplifying climate feedback loops. The death of the dinosaurs was not just a one-time event, but the result of the planet's inability to regain equilibrium after the catastrophic shock. The ocean acidification. The massive release of sulfur and carbon dioxide caused severe ocean acidification that wiped out the shelled plankton, including the tiny, beautiful foraminifera and coccolithophores. These microscopic organisms form the base of the marine food chain, and their sudden vanishing shattered the entire ocean ecosystem. The ocean's sudden drop in pH meant that the water itself became corrosive to calcium carbonate shells. The ocean, the cradle of life, became a chemical enemy to its inhabitants, dissolving their very defences. This chemical warfare against the smallest organisms proved to be the ultimate killer of the marine biome. The loss of these plankton also reduced the ocean's ability to act as a carbon sink, meaning that less atmospheric carbon could be absorbed. This created another feedback loop, accelerating the warming on land. The death of the ocean's microscopic life was the final, invisible link that sealed the fate of the macroscopic world. The Carnian pluvial event occurring just before the end Triassic, was not a major extinction but a massive, prolonged period of global rainfall. For 2 million years the world was saturated with endless, heavy rain. This led to massive environmental change, causing high stress and eliminating many species long before the main extinction hit. The massive increase in moisture allowed new plant life to flourish, changing the entire terrestrial ecosystem. This climatic shift was a major evolutionary filter, preparing the land for the dinosaurs by eliminating many of the heat-loving, arid-adapted reptiles that competed with them. The event shows that even a shift toward lushness can be a killer if the change is too rapid and sustained. The endless rain transformed vast arid deserts into swamps and lakes, drowning ecosystems that could not adapt to permanent moisture. It was a massive drowning that set the stage for the later volcanic terror. The End Guadalupian Purge. Just before the Great Dying, the End Guadalupian extinction pulse wiped out a massive 70% of all marine species. This sudden event was a dark precursor, showing the planet was already in deep trouble before the Siberian traps fully erupted. It was a terrifying warning shot fired across the bow of the Permian biosphere. This pulse is also linked to massive volcanic activity, but in a different region, suggesting that multiple eruptions may have been destabilizing the climate for millions of years. This demonstrates that the greatest mass extinction was a culmination of several smaller, devastating events, not a single, isolated catastrophe. The survivors of the End Guadalupian event were the few species resilient enough to make it to the main Great Dying. Their survival was only temporary, proving that when the planetary systems are fundamentally broken, even the hardiest creatures are merely delaying the inevitable final catastrophe. The Permian Reef collapse. The great, beautiful Permian reefs were already in severe decline during the Guadalupian pulse. The combination of environmental stress and rising sea temperatures caused them to weaken and collapse long before the main Great Dying hit. Their disappearance removed a vital buffer zone for marine life, making the final catastrophe all the more lethal. The collapse of the Permian reefs is a chilling reminder that ecosystems often fail in stages. The destruction of one foundational part, the reefs, creates a vulnerability that leads to the collapse of the entire system. The world's most complex habitats are often the most fragile under relentless stress. The reefs did not fully recover until the Middle Triassic, millions of years after the Great Dying. This long period without complex reef structures shows how profoundly the extinctions simplified the oceans. The silent, empty space where the reefs once stood is a testament to the magnitude of the loss. The Paleocene-Eocene thermal maximum. The Paleocene-Eocene thermal maximum, PETM, was a sudden, massive warming event that occurred 56 million years ago. While not a major mass extinction, it was a rapid climate shock causing the average global temperature to spike by 5 to 8 degrees Celsius in just a few thousand years. This rapid warming caused massive ecological disruption, especially in the oceans. The warming led to severe ocean acidification and a rapid drop in oxygen, stressing life globally. It serves as a near-perfect natural experiment in what happens when carbon is released rapidly into the atmosphere. The PETM is marked by the dwarfism of mammals, a temporary return of the Lilliput effect. Horses and other animals shrank in size during this hot period, proving that high temperatures force life to adapt by becoming smaller and more efficient. The sudden heat was a temporary evolutionary hammer that favoured smallness. The end Permian coastal death. The most immediate and total death during the Great Dying occurred along the coasts. The combination of ocean acidification, rising hydrogen sulfide, and massive temperature spikes made the shallow coastal areas instantaneous death zones. Life could neither flee to the toxic land nor survive the boiling poisoned water. The total collapse of coastal life removed the vital link between the land and sea ecosystems. Shorebirds, coastal plants, and shallow water fish were wiped out in a single prolonged catastrophe. This ecological break meant that the post-extinction recovery had to start from a completely separated baseline. The fossil record from coastal regions shows a complete, terrifying loss of biodiversity, a near-total wipeout of all life forms. The end Permian coast was arguably the most dangerous place on the planet for millions of years, a perpetual graveyard where the land and sea traded chemical death. The Jurassic-Cretaceous boundary. While the Jurassic-Cretaceous boundary, JC, is not considered a mass extinction, it marks a significant turnover in species, especially marine life. This minor crisis is linked to a period of global sea level fall, which stressed shallow water habitats and caused regional extinctions across the world. This event eliminated many of the marine reptile species that had survived the end Triassic, proving that even a minor climate shift can finish the job of a previous catastrophe. The persistent instability of the Mesozoic era kept life constantly challenged, preventing the formation of overly specialized ecosystems. The turnover is also noted for the replacement of older, ammonite species with new, faster evolving forms. The pressure of the crisis created a selective filter, favouring those species with high reproductive rates and fast mutation. Even minor extinctions act as powerful evolutionary accelerators, purging the slow and favouring the quick. The dinosaurs' enduring ghost. The KP extinction created a long-lasting biological and evolutionary ghost, the permanent absence of large terrestrial reptiles. The niche that dinosaurs occupied remained empty for millions of years, eventually filled by large mammals. The shadow of the tyrannosaur still defines the physical limits of life on Earth. The mammals that evolved after the extinction were structurally different from the dinosaurs, built for high endurance and warm-bloodedness. The KPG event didn't just kill, it mandated a complete redesign of the dominant land animal, permanently ending the age of cold-blooded, massive reptilian dominance. This permanent void created by the dinosaurs' disappearance is a powerful reminder of how absolute a mass extinction can be. The complete removal of an entire ruling class of life allowed a long-suppressed group, the mammals, to finally and fully take over the planet. Our existence is owed entirely to a single chaotic world-ending event. The Hangenberg event. The final pulse of the Devonian extinction is called the Hangenberg event, a sharp, massive die-off that occurred at the very end of the period. This event is linked to a massive global sea level fall, causing widespread anoxia and climate chaos that finished off many of the remaining species. The Hangenberg event represents the final crushing blow to the Devonian biosphere. After millions of years of stress, the ecosystem's resilience was gone, and the final sea level drop proved fatal. It shows that even a small final shock can destroy a system that is already on the verge of total collapse. This pulse is believed to have been particularly devastating to life in the shallow marine environments and transitional land-water zones, proving that the crisis returned to its original target. The Hangenberg event was the final, absolute silence that ended the Age of Fishes and cleared the stage for the next geological era, the Mesozoic Marine Revolution. Following the end Triassic extinction, the oceans underwent the Mesozoic Marine Revolution. This was a major evolutionary shift where marine predators evolved powerful crushing jaws and shells, evolved to be thicker and more armoured. The crisis had initiated an arms race between prey and predator that defined the next 150 million years. The revolution was a direct response to the ecological vacuum left by the Triassic collapse. The survivors evolved rapidly, filling the empty neos with new, highly specialised predators. The oceans, though scarred, used the extinction as a chance to radically upgrade their inhabitants, favouring speed and armour. This evolutionary explosion proves that extinction can be a creative force. The death of the old guard allows the new generation to evolve more resilient, specialised forms. The terror of the Triassic gave birth to a faster, stronger and more lethal ocean ecosystem that would rule until the KPG impact, the Tethys Sea crisis. The Tethys Sea, a massive ancient ocean that separated Pangaea, was a major centre of diversity. During the Triassic extinction, this massive body of water suffered severe anoxia and temperature spikes, leading to immense death. The contamination of this core oceanic highway severely limited the ability of life to migrate and survive elsewhere. The vast size of the Tethys Sea meant its collapse was a global problem. Its toxic waters were the source of contamination for the entire planetary ocean system, accelerating the spread of anoxia and chemical poisoning. The Tethys was the planetary patient zero for the Great Dying's marine trauma. The slow, agonizing collapse of this central ocean is a tragic story of global connectivity. The destruction was not isolated. The poisoning of one major ocean was enough to condemn the entire marine biosphere. The Tethys Sea is a silent, terrifying reminder of the interconnectedness of all life. The Holocene shadow scientists agree that the Earth is currently entering its sixth mass extinction event, often called the Holocene or Anthropocene extinction. This event is unique because it is the first extinction driven entirely by the actions of a single species, humanity. The terror is that we are the asteroid, the volcano, and the gamma ray all rolled into one. The current rate of species loss is estimated to be 100 to 1,000 times the natural background rate. This rapid pace of disappearance mirrors the speed of the great past catastrophes, signalling a profound and immediate crisis. We are creating a permanent geological gap in the future fossil record through our own actions. The current extinction is not a sudden total collapse, but a global stripping of biodiversity, driven by habitat loss, pollution, and climate change. It is a slow, silent massacre that affects every ecosystem, from the deepest ocean to the highest mountain, proving that modern life is universally vulnerable to human activity. The coral grave, coral reefs, the rainforests of the sea, are currently undergoing a mass die-off due to ocean acidification and warming. The oceans are absorbing massive amounts of human-emitted carbon dioxide, making the water corrosive to coral skeletons. We are chemically replicating the conditions of the end-Triassic extinction in real time. The loss of these complex ecosystems has massive global consequences, as reefs support 1/4 of all marine life. Their disappearance creates vast, dead zones and removes crucial buffers against storms. The ocean's most valuable real estate is dissolving, removing the foundation of the marine food web. The bleaching of corals, where the polyps expel the symbiotic algae that sustain them, is a terrifying, visible sign of planetary stress. These bright, ghostly white skeletons are the tombstones of a complex, vibrant ecosystem, showing that the silent chemical warfare that killed the ancient world has returned with a vengeance. The Arctic's warning. The rapid melting of the Arctic permafrost is releasing vast amounts of ancient methane gas, a potent greenhouse gas 25 times more effective than carbon dioxide. This process is creating a new climate feedback loop, echoing the dangerous methane release that occurred during the end-Triassic and Great Dying events. The methane is a ticking time bomb of ancient carbon, previously locked away in the frozen ground. Its release risks triggering a sudden massive spike in global temperatures that could overwhelm the ability of modern ecosystems to adapt. The Arctic is releasing the ghost of past extinctions into the modern atmosphere. This feedback loop is a perfect demonstration of the planet's instability under stress. We initiate the warming, and the Earth's own ancient carbon reserves take over the job of accelerating the catastrophe. The Arctic's melting ice is not just a sign of change, it is the physical mechanism for planetary self-destruction. The mass amphibian collapse. Modern amphibians are facing a catastrophic global collapse, primarily due to the Chytridia mycosis fungus, which is accelerated by climate change. This biological plague, combined with habitat loss and pollution, has driven hundreds of species to the brink, echoing the sudden vanishing of amphibians during the Triassic. Amphibians are the biological canaries in the coal mine, their permeable skin making them highly sensitive to minute changes in water quality and temperature. Their widespread, simultaneous disappearance is a terrifying warning signal that the world's freshwater and transitional zones are becoming universally toxic. The modern fungal plague is an example of an introduced killer, spread globally by human activity and amplified by a stressed warming climate. This massive die-off proves that the greatest threats in the Holocene are often microscopic, silent, and easily moved across once impassable geographical boundaries. The biodiversity crisis. The defining characteristic of the sixth extinction is the catastrophic loss of biodiversity, particularly in the most diverse regions. The Amazon, coral reefs, and other evolutionary hotspots are being destroyed at an unprecedented rate, eliminating the planet's genetic library before we even have a chance to catalogue it. We are living in an era of defaunation, a silent environmental crime where complex ecosystems are stripped of their animals, leaving behind an impoverished, simplified world. This loss of complex interactions makes the remaining ecosystem far more vulnerable to future shocks and collapses. The current crisis is not just about the death of a few famous species, it is about the destruction of the ecological fabric itself. We are removing the safety nets and resilience that define a healthy planet, ensuring that when the next major climate event hits, there will be nothing left to stop the total collapse. The silence of the bees. The collapse of insect populations globally, often called the insect apocalypse, is a terrifying, under-recognized component of the current extinction. Insects are the foundational life forms that pollinate most of the world's plants and form the base of many food chains. Their sudden vanishing signals a systemic failure. The widespread use of pesticides, coupled with habitat loss and climate change, is silently removing the most numerous and vital creatures on the planet. The loss of pollinators means that the next generation of plants is already doomed, setting the stage for a catastrophic collapse of the plant kingdom. The silence of the bees, and other insects is an ecological warning sign that transcends any single regional disaster. It proves that the entire terrestrial ecosystem is failing at the most fundamental level, signalling an impending global famine and collapse of the plant kingdom, the foundation of all life. The ocean's heat. The oceans are absorbing most of the heat trapped by human-emitted greenhouse gases, leading to unprecedented warming. This intense heat is causing massive thermal stress on marine life, especially in the deep sea and tropical zones. The largest body of water on Earth is rapidly turning into a feverish bath. This warming is leading to an expansion of oxygen-depleted zones, the dreaded ocean anoxia, echoing the kill mechanisms of the Permian and Devonian extinctions. The life-sustaining oxygen is being stripped from the water, turning vast areas of the deep sea into uninhabitable biological deserts. The ocean heat acts as a final filter, pushing already stressed species past their breaking point. It demonstrates that our pollution does not just affect the air we breathe, but fundamentally alters the chemistry and thermodynamics of the entire planet. The sea is warming, and its fever is our greatest threat. The microplastic scars. The entire planet is now covered in microplastics, the invisible scars of human activity. These tiny, non-biodegradable fragments are found in the deepest ocean trenches, the Arctic ice, and even in human organs. This pervasive, unseen pollution is poisoning ecosystems at the most microscopic level. The microplastics accumulate in the food chain, physically blocking the digestive systems of small organisms and releasing toxic chemicals into their tissues. This chronic planetary poisoning is a subtle but relentless stressor, weakening the resilience of species to other shocks like heat and acidification. The pervasive nature of microplastic pollution is a unique horror of the Anthropocene. It is a permanent geological residue that will mark our era in the future rock record, much like the iridium layer marks the KP extinction. We are leaving behind an indelible, microscopic signature of our own self-destruction, the land-sea uncoupling. The current extinction is causing a massive uncoupling between land and sea ecosystems. The rapid loss of coastal habitats, wetlands, and estuaries is breaking the vital exchange of nutrients and energy between the two biomes. This ecological break isolates ecosystems and severely limits the ability of species to migrate and adapt. The destruction of coastal mangroves and salt marshes removes the crucial nursery zones for countless marine species. It also removes the natural barrier against storms and rising sea levels, making coastal areas doubly vulnerable to the climate crisis. The planet's edge zones are being erased. This uncoupling echoes the Devonian and Triassic crises, where the contamination of one domain quickly led to the collapse of the other. By removing the boundary life, we are ensuring that the inevitable future shocks will be felt simultaneously and catastrophically in both the land and the sea. The extinction debt. The most chilling modern concept is extinction debt. This is the phenomenon where species currently alive are already doomed to extinction due to past habitat loss and pollution, even if we stop all harmful activity today. We are living with a biological debt that must be paid in future species loss. This debt means that the true extent of the sixth extinction is not yet visible. We are only seeing the initial deaths, but the biological mechanism for a far greater, delayed die-off is already locked in. The future is already scarred by the environmental crimes of the present. Extinction debt proves that the current crisis is irreversible and will unfold for centuries. We are witnessing the slow-motion destruction of ecosystems that cannot be repaired in the span of a human lifetime. The shadow of the sixth extinction is a permanent curse on the future, a terrifying, guaranteed fate. The end of giants. Just as the dinosaurs and proto-mammals were targeted, the current extinction disproportionately targets large mammals, elephants, rhinos, great apes, and large predators. Their size, slow, reproductive rates, and need for vast territories make them easy prey for human activity and habitat fragmentation. The removal of these massive megafauna has massive long-term consequences for the ecosystem. Their grazing, migration, and seed dispersal patterns shape entire continents. Their disappearance removes a vital ecological memory, leading to a permanent simplification of terrestrial habitats. The current death of the giants echoes the KPG event, proving that size is a fundamental liability when the planetary environment shifts violently. The world that remains is smaller, humbler, and less vibrant, a biological echo of the great, thriving ecosystems that once defined the planet. The permanent scar. The current extinction will leave a permanent scar on the planet's evolutionary tree. The loss of entire lineages, families, and orders will mean that the evolutionary history of the planet will be permanently rewritten. The life that returns in the distant future will look fundamentally different from the rich complexity of today. The fossil record of the Anthropocene will be defined by the sudden, mass vanishing of species followed by a layer rich in microplastics and other human artifacts. Our technological debris will be the enduring tombstone of the creatures we destroyed. The true horror of the sixth extinction is the permanent loss of genetic information. Millions of years of unique adaptation, ingenuity, and evolution are being erased in a single century. The future biosphere will be an impoverished echo of the past, forever lacking the brilliance we extinguished. The evolutionary bottleneck. The current extinction is creating a severe evolutionary bottleneck. Only the most generalist, rapidly reproducing and pollution-tolerant species will make it through the crisis. These survivors will form the limited genetic pool from which all future life will evolve. The planet's recovery will be slow and limited, built on the foundations of the few hardy survivors, weeds, rodents, pests, and bacteria. The beautiful, specialized creatures are already doomed, leaving a future world populated by only the toughest and most adaptable generalists. This bottleneck proves that mass extinction doesn't just kill, it edits the genetic future of the planet. The diversity of the past will be replaced by the monotonous resilience of the few, a biological simplification that will haunt the planet for hundreds of millions of years. The folly of resilience. Past extinctions show that the most resilient species, those that survive the first shock, are often later killed by the ensuing chaos or the secondary shocks. The Earth's instability during a crisis is the ultimate killer, not the initial event. Survival is never a guarantee, even for the toughest. The current crisis is built on multiple interacting shocks: climate change, pollution, and habitat loss. This relentless combination ensures that even highly resilient species are pushed past their ability to cope. The terror of the Holocene is the sheer volume of simultaneous threats. This lesson from the past, that resilience only delays the inevitable, is the most chilling aspect of the modern crisis. We are operating under the dangerous delusion that nature will bounce back, when history proves that a broken system often spirals into total collapse, taking its toughest inhabitants with it. The quiet deserts, the current global desertification, caused by climate change and unsustainable land use, is turning massive swathes of once productive land into barren deserts. This process echoes the formation of the arid, life-barren interiors of the supercontinent Pangaea during the Great Dying. The rapid expansion of the deserts removes crucial land for agriculture and forces remaining life into smaller isolated pockets. This habitat fragmentation is a major driver of extinction, creating islands of life that are too small to sustain genetic diversity or withstand future shocks. The quiet spread of the deserts is a form of silent, creeping extinction. The loss of soil, moisture, and vegetation removes the very foundation of terrestrial life. The Earth is slowly being stripped of its green cover, leaving behind a scarred, increasingly barren planet that will struggle to support any complex life. The self-inflicted iridium. The KPG extinction was marked by an extraterrestrial iridium layer. The Anthropocene will be marked by a layer of technological waste and pollution. This future geological layer will contain plastics, aluminum, concrete, and high concentrations of industrial chemicals, a permanent planetary signature of human impact. This layer will be our iridium, proving to future geologists that a sudden, unique force fundamentally altered the planet's systems. Instead of a cosmic shock, the next great boundary will be defined by the discarded materials and fossil fuel byproducts of our own civilization. The horror is that this layer is already forming. It is a slow, self-assembled tombstone, a planetary memorial to the species that created the first global extinction driven by consciousness. We are actively writing the final chapter of the modern era in a layer of synthetic, toxic material. The climate chaos whiplash. The modern climate is moving into a state of extreme volatility, where stability is replaced by chaotic, unpredictable swings. Massive droughts give way to colossal floods. Extreme heat is followed by sudden, intense cold snaps. This climate whiplash is the same unstable chaos that plagued the planet during the Devonian and Triassic crises. This volatility is a lethal challenge to all ecosystems, as species adapted to one extreme are instantly eliminated by the next. The constant, unpredictable shifts prevent the establishment of stable communities, making it impossible for species to adapt or recover. The chaos proves that the Earth's atmosphere is losing its ability to regulate itself. We have pushed the climate system past its natural equilibrium, entering a terrifying new phase of intense, rapid, and unpredictable change. The instability itself is the key killer of the sixth extinction. The survivor's inheritance. The survivors of the sixth extinction will inherit a genetically impoverished, simplified world. They will be the tough generalist species that thrive on disturbance and decay, similar to the small mammals and fungi that inherited the Earth after the KPG and Permian events. The planet's recovery will take millions of years, limited by the small, uniform genetic pool of the survivors. The immense biodiversity we know today will be a lost relic, replaced by a monotonous array of hardy, resilient but genetically limited life forms. The inheritance of the survivors is a terrifying mirror of the past. They will not inherit a utopia, but a scarred, unstable world where the shadow of human folly lingers in the geological record. The future belongs to the few who can tolerate the scars we leave behind. The patterns return. The modern crisis adheres chillingly to the patterns of the past. Massive carbon injection, Siberian traps, ocean acidification, Permian, widespread anoxia, Devonian, and rapid climate shock, KPG impact. We have managed to replicate all the lethal mechanisms of the 5 great extinctions simultaneously. This synthesis of past terrors makes the 6th extinction potentially the most effective killer of all time. We are not facing one single threat, but a coordinated planetary assault that leaves no escape route for life, echoing the relentless dual crises of the Ordovician. The ultimate horror is recognizing the pattern. The death of the ancient worlds was not an accident. It was a consequence of planetary systems crossing critical thresholds. We have identified these thresholds and are now deliberately crossing them, ensuring the final tragic return of the Great Silence. The next silence's name. The 5 previous extinctions are named after geological periods: Ordovician, Devonian, Permian, Triassic, and Cretaceous. The next extinction, the one we are in, will likely be named the Anthropocene extinction, meaning the age of man. It will be the first time that a single species name is synonymous with global, ecological collapse. This naming is the ultimate indictment of our species. Our legacy will not be the wonders we built, but the destruction we caused, a silent, permanent memorial etched into the geological record. We will be remembered not as the planet's stewards, but as its final, catastrophic force of nature. The terror is that we have become the Siberian traps of the modern age, a single species capable of altering the entire planetary system. We are releasing carbon at a rate faster than almost any historical geologic event, setting the stage for the same ocean anoxia and temperature spikes that killed the trilobites and the dinosaurs. The next great silence, the sixth extinction, will not be a mystery solved in a fossil bed, but a self-inflicted wound. We have peered through the cracks of history, tracing the deadly pattern of 5 cosmic tremors that erased nearly all life. Every silence, every shadow we uncovered, whispers a single, terrible truth. The Earth is capable of unimaginable violence. Don't let these stories fade back into the darkness. Subscribe and ring the bell to join us next time as we decode the secret languages hidden within forgotten cultures. Before you go, ask yourself one chilling question, tied to the motif of Cronus's inverted hourglass. If the past is destined to repeat, are we the victims or the architects of the sixth silence? A highly dramatic close-up shot of a single fossilized trilobite shell, half buried in sand, intensely illuminated by a cold, spectral light source. Powerful oil painting using extreme chiaroscuro, light-dark contrast, and theatrical composition like Caravaggio. Heavy dramatic shadows, a single intense light source, profound emotional expression, museum quality. Negative prompt, flat light, digital, photo, photography, CGI, sketch, cartoon, modern, simple. The history of life is not a story of continuous progress, but a series of desperate escapes. From the gamma-ray ghost of the Ordovician to the poisonous breath of the Great Dying, existence is defined by its near misses. The remnants left behind, that thin, dark layer of iridium, the scorched carbon spheres, are the symbolic keys to the horror. They prove that destruction is never truly erased. It is merely hidden in the strata, waiting for the conditions to return. Sleep now if you can, knowing that the greatest killer in history is not an asteroid but the terrible quiet of a world that has forgotten how to breathe.